Welcome back, Math 098. We're going to talk about Section 3 of Chapter 8. And what you'll notice, at least with the first couple problems, is that we've done things like this. The only difference is, as we get later to these notes, we'll be doing more quadratic models, more than just a quadratic formula, but the quadratic formula is going to be big in this. So in the very first problem, what I would do, because this isn't really set up in a quadratic form, like it's not something squared, like this piece is not really helpful. What I would do, what I would probably do is just leave the minus 5 on the left side. That way I can just add the square root of x plus 1 over, and adding something to 0 is just going to be that thing. So then from here I can just square both sides. And you may remember doing this in an earlier chapter. So then we'd have x squared minus 10x, because don't forget you have to FOIL that or distribute. So there's a minus 5x, and negative 5 times negative 5 is positive 25. And then from here, now we have a quadratic model. So you can see where we're going with this, where now you want to set the equation equal to 0, and you do that by subtracting x over. So it becomes minus 11x. Subtract 1 over. And when we did this before, these were factorable things. So when they were factorable, well, it looks like this one actually is as well, because 8 times 3 gives me 24. To make it negative 11 be negative 8 and negative 3. But if you forget, what you should realize is that that you could do the quadratic formula on this. So we're looking at x minus 8, x minus 3. So by the zero product property, we could then deduce that x could equal positive 8 or positive 3. Now you may remember from an earlier chapter as well, we talked about extraneous solutions. And anytime you square, right here we squared both sides, you may have an extraneous solution. So just double check. Let's try 8 first. Well, 8 plus 1 is 9. The square root of 9 is 3. 8 minus 3 is 5. Minus 5 is 0. So 8 is good. If you try 3, 3 plus 1 is 4. Square root of 4 is 2. 3 minus 2 is 1. Minus 5 is not 0. So that was an extraneous solution. The only answer that works is 8. And if we actually looked at the graph of this, which I could show you, x minus the square root of x plus 1 minus 5 will only cross the x-axis once. So let's go ahead and look at that. X minus the square root of x was plus 1. Yep. Over minus 5. If I look at the graph of that, you see how it just stops right here, because if it went backwards, it would have hit at negative 2, except it's a domain issue. Sorry, at 3. So as we look at the graph, 1, 2, 3, 4, 5, 6, 7, 8, it has a 0 at x equals 8. So that can confirm, that could help you understand why there's only one correct answer, even though algebraically it looked like there should have been 2. Please write down any questions you may have and bring them to class or email me. We can set up a Google Meet. We can talk about any of this. I'm sure you're tired of hearing me say that, but I feel like that's necessary. So again, as we look at this next problem, right now it doesn't even look like there's a quadratic in here, but we practice getting the same denominator on all of our pieces. And the shared term in all of these is that we have an x in all of them. Well, we can get an x in this one by multiplying by x. So I have to multiply the top by x as well. And this one has an x, and the other ones have x plus 1. So we'd have to multiply this piece by x plus 1. And by getting all of the denominators to be the same, which now they are, that means the numerators must make a true statement, where I'm looking at 5x squared minus. Now make sure I'm using a bracket for my parentheses, because you have to FOIL this out and then distribute that negative in there. I like to do this piece by piece, so As you FOIL, you get 1x plus 4x, that's 5x. And 4 times 1 would give me 4. It's equal to 3. So now it's starting to look like a quadratic. Just make sure that you distribute that in there. So we're looking at 4x squared and be minus 5x. This would be minus 4, but I also have to subtract a 3 over. And I don't really feel like trying to factor that. Like this one was pretty easy to factor. So this might be where using the quadratic formula will be your friend. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That should have been negative c. Sorry about that. All over 2a. Well, 2 times 4 is 8. So if I were doing this problem, I would go ahead and type in under the radical the discriminant. You may remember we talked about that. 25 minus 4 times negative 7. So that's 137. I don't believe that breaks down at all. So I would prefer to see this answer. Now this one you don't actually have to check for extraneous because at no point did I square both sides. I guess I should check for extraneous because we cannot divide by 0. It's been a while since we've talked about that. But neither 0 or negative 1 occur in these two answers. Because the square root of 137 is not a rational number. I don't know what the square root of 137 is. I know it's smaller than 12. There we go. Something like that. But I'd rather see this answer because that's telling me that you knew how to do the problem and you didn't just graph this and saw where the intersection points are. So that's where I'm coming from on this. So how can we make this a little bit more complicated? It's still a quadratic model even though this is to the 4th power. But sometimes what I'll do, and I'm not saying I'm going to do it this year, is I have students think about, well, think of p to the 4th as being like x squared in our quadratic models. So that means that x would be equal to p squared. So it's taking on the form x squared minus 7x minus 144. And in the quadratic formula is x equals, negative b plus or minus the square root of b squared minus 4ac all over 2a. But the difference is now is instead of x equals, it's going to be p squared equals. Because x in the context of my problem is equal to p squared. So x equals negative b plus or minus the square root of b squared. 7 squared is 49. Minus 4 times a times c all over 2a. 2 times 1, you can just leave it as 2. So now when we simplify this, we'll just have one more step at the end is the square root to solve for p. So as I go to my calculator, I think this is a pretty problem where, 49 minus 4 times 1 times negative 144. I think that's a nice number. And it is, because the square root of 625 is 25. So we can simplify this to p squared equals 7 plus 25 all over 2 and 7 minus 25 all over 2. That's how we use the quadratic formula. So what that means is this was factorable at the beginning. So 7 plus 25, that's 32, divided by 2 would give me 16. And while I'm at it, I might as well just go up and do 7 minus 25 all over 2. It's negative 9. So p squared equals 16. And I meant to write p squared here as well. Equals negative 9. And so when we solve this, we square root both sides. And don't forget, I want two answers, plus or minus. And then this one, you do get two answers. And now that we've learned about imaginary numbers, the square root of a negative gives me an I in there. Square root of 9 is 3. Again, write down any questions you have and bring them to me, and we can talk about that. And you may even remember in Algebra 2, the fundamental theorem of algebra is the degree of your polynomial is how many answers you should have. So it's a fourth degree polynomial. We have 1, 2, 3, 4 answers. And I would really explain the next one really using the same logic. I'm not going to write all of this down, but think about how this could be squared. So something squared minus something, 2 times something minus 3 equals 0. So in the quadratic formula, we would normally say x equals. Well, now, instead of being x equals, it's x plus 2 equals. I don't want to over-explain it, so I think this makes sense. Because normally it's x squared minus 2x minus 3, and then the quadratic formula is x equals negative b, yada, yada, yada. But the difference is instead of x, we have x plus 2. So that's why when we do the quadratic formula here, 2 plus or minus the square root b squared minus 4. Notice I'm using the a values are in front of these. A is 1, b is negative 2, and c is negative 3. 4 times a times c, all over 2a. Again, a is 1. And I could actually do this in my head. I hope you could as well. That 4 times negative 3 is negative 12, so 4 plus 12 is 16, and the square root of 16 would be 4. So we're looking at 2 plus 4 divided by 2, and 2 minus 4 divided by 2. And remember the equation's x plus 2 equals each of those. So as you simplify, that would be 6 divided by 2 is 3, and subtract 3 over, and you would get x equals 1. And then on this one, 2 minus 4 is negative 2, divided by 2 is negative 1, and subtract 2 over from that. Negative 1 minus 2 would give me negative 3. So again, I'm hoping all of this makes sense. If not, write down your questions and bring them to class. Or email me and we can set up a Google Meet. I have 3 more examples. I don't want to rush through, and I know I have to make another video anyway. So I'm going to stop here. If you want to work through some of your assignment, that's fine. And then come back to the second video to finish up these notes. And I'll see you there.